This is Dr. Lewis going through some topics that will be covered in the upcoming assessment, replacing the written exam, for my course called Structure and Reactivity. Just to remind you that my lecture course was rewritten, so if you look at past papers, don't rely on that to be what the paper will be. For my question only will be for this time. So I have rewritten it to concentrate on organic chemistry, and I've removed topics such as VSEPR theory and molecular orbitals of molecules such as oxygen and nitrogen. So as part of the organic chemistry lecture course, there was a section on nomenclature. So you'll find this in lecture L3, organic chemistry. So in nomenclature, there are a few guidelines to go through. Firstly, identify the longest carbon chain. So if it's obviously C7, it would be heptane. If it's C6, it would be hexane, etc. Identify the functional groups. Is it an aldehyde, ketone, or carboxylic acid? And remember there are a list of priority in functional groups, so you name the molecule after the highest priority one. So that was, I gave you the main ones in order in the lecture notes. Then you start adding substituents, so identify things like methyls and chloro and fluoro and bromo, and you number them to give the lowest numbers you can. And you list those substituents in alphabetical order, so not necessarily by the number, but simply in alphabetical order. So chloro is before fluoro, before methyl. And whenever you get a number or separating from a name, have a dash. So you could have a name like chloro, then dash 2, then dash another name. But otherwise, if a substituent joins on the main name, such as methyl heptane, then you have no gaps between methyl and heptane. So these examples here, I should say, are a lot more difficult than the ones you'll get in the exam. So if you can do these, you should be able to do the exam ones quite easily. So here, first of all, count the longest carbon chain. It's 1, 2, 3, 4, 5, 6. Well, that can be 6, so it's C6. And it's an aldehyde, so there's an H there. So it's based around hexanal. And then you're going to add the substituents. So the numbering will start here. 1, 2, 3, 4, 5, 6. And we've got a methyl and a bromo. Bromo, although it's number 4, it's alphabetically before methyl. So it's going to be 4 bromo, then a dash, and then the methyl, which is in 2 position, methyl, and that joins directly on to the aldehyde. So we'll do that down here. So here we've got an alcohol and an alkene, and the longest chain is 1, 2, 3, 4, 5, 6 again. So it's C6. And alcohol is a higher priority than alkene, so it would be named as a hexene all. So we've got 1, 2, 3, 4, 5, 6. So we've got a methyl, the alcohol is in the 2 position, and the alkene is in the 4 position, and we haven't actually got any substituents attached to that. The other thing we have to add is the stereochemistry. So look at that double bond. The highest priority groups, as in there's 2 carbons and 2 hydrogens, the 2 carbon groups are on opposite sides of the double bond. So we either call that trans or alternatively E. So first we'll call it trans, and then we've got hex, and the position of the double bond is 4, ene, and then the position of the alcohol is 2, ol. And we'll move that one down so there's room for that. So here again we've got an aldehyde, now an alkene, and the longest chain is 1, 2, 3, 4, 5, 6 again. So once again it's a hexenal. And the substituents will be named numbered, so the double bond is at 4 and the methyl is at 2. But now the double bond, the two carbon groups, which are higher priority than the two hydrogens, are on the same side of the double bond, so that's called a cis. So we'll call that cis, cis, and then the methyl, because that's only a substituent, 2 methyl, and then join that on to hex, 4 ene al. Okay, and the alternative, remember, for trans is E, and then the rest of it is the same. And for this one, Z stands for cis, and again the rest of it is the same. And here we've got an ester, so there we've got CO2 and R, so there, that's a methyl group attached to there. So it'll be named as, remember, when you name an ester, that's when you do have a gap. So it'll be named as a methyl benzoate, because it's benzoic acid is the carboxylic acid. Now, the substituents are on the benzene ring, so they'll be named starting with 1, and we'll go around this way, 2, 3, 4, 5, 6. So why do we go around that way? Well, we've got two substituents, so it wouldn't matter if it was that way, 1, 2, 3, 4, 5, 6, or that way. But in this case, the one that's named first is chloro, so we'll call that 3 rather than 5. So the full name is methyl, then a gap, then 3 chloro 5 fluoro, and then we join that name onto benzoate. And finally we'll squeeze the last one. We can might as well go up the way this time. So the longest chain is going to be 1, 2, 3, 4, 5, 6, 7, 8, and it's an alcohol, so it's going to be an octanol. And then we've got substituents at numbering from here 3, 4, 5, 6, 7, 8. There's 2 methyls, well, altogether 3 methyls, so it's going to be a trimethyl octanol. And then we have to say, where are these methyls attached? Well, one is at the 4 and 2 of them are at 5, so we actually say 4, 5, 5 trimethyl octan 3 ol to show where the hydroxy is. So starting from over here, we've got 4, 5, 5 showing where the methyls are, 4, 5, 5 trimethyl, and then join that onto there, octan 3 ol. just on the page. And that's it. So I say that is more difficult than you'll be asked to do. But you'll have plenty of time.